Today we are going to enter into the world of a new kind of motion, that is circular motion. By name itself, now our path is not a straight path. Now our path is on a circular path. And in that also, we have to study especially one special type of circular motion, and that is uniform circular motion. So what is our topic? You need to understand uniform circular motion. Okay, so before starting understanding this concept, we should understand one of the previous concept based on our previous knowledge. What is that? Because that is very essential to understand this type of motion. So I have made a flow chart here where I have written force causes non-uniform motion. Non-uniform motion means it is a situation of acceleration. Acceleration is considered when there is a observation of change in velocity, and velocity is a vector quantity, so it covers two parts: magnitude of velocity as well as direction of velocity. So force causes non-uniform motion. Non-uniform motion means it is a situation of acceleration. Acceleration is considered when there is a change in velocity, and change in velocity is considered either the magnitude is changing or direction. If both are changing, then also it will be called a change in velocity. So either magnitude changes, direction remains fixed. If direction keeps on changing, magnitude remains fixed, or both are changing. In all situations, we will consider that there is a change in velocity, and if there is a change in velocity, that means acceleration is there. If there is an acceleration, that means it is overall a situation of non-uniform motion, and if there is a non-uniform motion due to any reason, then it must be a presence of force behind all this situation. Without force, it is not possible. So this is very important flow chart to understand, because this is very much required to understand our topic. Okay, so now circular motion broadly we categorize into two categories: uniform circular motion and non-uniform circular motion. Please take it care that it's not a uniform motion, it is a uniform circular motion. Okay, so there is always a confusion between uniform motion and uniform circular motion. You will find out there are differences between uniform motion and uniform circular motion. So we'll come to know about that. Now, when it is called uniform circular motion, a brief idea I am giving you, when there is change in direction only of the moving object, not the magnitude of velocity. Means when only the direction changes of the object continuously during its journey, but magnitude is not changing, that means the body is moving with constant speed but with a continuous change in direction, then we consider it is a uniform circular motion. So what is the definition of uniform circular motion? When a body moves on a circular path with a constant speed. If we take another category of circular motion, that is non-uniform circular motion, here since it is a circular path, the direction has always to be changed, as well as if the magnitude also keeps on changing. So here both the things are changing. Direction is changing as well as magnitude is also changing on a circular path. Then it comes under the category of non-uniform circular motion. But basically we have to concern our discussion with this motion only, uniform circular motion. This is our topic. Now, to understand uniform circular motion in detail, one illustration we are going to take here. But keep in mind this flow chart. This is very important to understand. Okay, so I have drawn some figures here, and with the help of these figures, we will try to understand when our motion becomes a uniform circular motion. Okay, so now suppose in situation 1, an object is moving from A to B with a constant speed 5 meters per second. So in this path, neither the direction is changing nor the magnitude of velocity. So that means body is doing uniform motion because neither direction is changing nor the magnitude of velocity. So coming to the next situation here. Here I have taken a situation when an object is moving from A to B with a speed of 5 meters per second, directed from A to B, and then it takes a turn towards C with the same speed. Now at this junction at B point, you can observe that there is a change in direction observed. Now whenever there is a change in direction, that means at that point change in velocity will be observed. If the change in velocity is observed, that means at that point body will be said in acceleration. If it is acceleration, at that point body is in the non-uniform motion, and if it is non-uniform motion, that means a force is there. So that means here the force is required, but for what? To bring change in magnitude of speed or change in direction. So here you can see the speed remains same. So that means the force is not bringing any change in speed. Then what it is it bringing? It is bringing change in direction. So at this junction, a force is applied to change the direction of the object. Suppose what if the force was not applied? Then obviously the body will track the same path, and the C point will not be here, C point will somewhere here. And in that situation, the speed is same, direction is same. That means the body has a tendency to do uniform motion. But due to force, its uniform motion tendency has vanished, lost, because due to force it has to change the direction. And if there is a change in direction, then at this junction the body is said to be accelerated due to force, and that force is bringing change in direction. Take care of that. There is no change in magnitude of velocity, that is speed remains same. Now coming to this situation. Suppose again A to B, it is moving with 5 meters per second. Then from B it takes turn towards C, so B to C, and then C to A, and continuously. Now, do you think that moving from A to B, a body has same velocity as it is moving from B to C? No, because although the magnitude is same, but the direction is different. So that means here also there is a change in velocity observed at junction B. And obviously, again the speed is not changing. Then what is changing here? Direction. What is bringing change in the direction? Again, force is there. Similarly, at C junction also, it has to turn towards A. So at this junction also, a force is needed because it has to change the direction. At A junction also, because it has to move from A to B again. So this means wherever there is a requirement of change in direction, then force should be there. So at this kind of motion, in this kind of motion, we observe 3 times force is needed. For what purpose? To change the direction of the object. So 3 corners, 3 times force is required. That means 3 times change in velocity is observed due to change in direction. Now coming to this path. This is square path. Can you think why it's square path I have made? Because you can see here all the time the speed remains constant. Here I have not changed the speed. Okay, at this square path, what number of times the force has been applied and for what purpose? So again you can see at all these junctions at A, B, C, D, force is required because at 4 corners it has to change the direction 4 times. So 4 corners, 4 times accelerated, 4 times change in velocity will be considered due to change in direction. That means 4 times force is required. So that means whatever number of times you have to change the direction, that many times the body is considered to be accelerated, and for that many times only force is required. So 4 times direction has changed, so 4 times force is required. Similarly, suppose we are taking a regular pentagonal path. So there will be 5 corners, so 5 times force is required. For what purpose? Again, 5 times direction is supposed to be change at the all corners. Suppose I have taken hexagonal, then for hexagonal also you have to take how many times force is required? 6 times, because 6 corners are there to where the direction is supposed to be changed. Similarly, if we take heptagonal path, that means 7 times is needed. Octagonal path, then 8 times. Nonagonal type of path, then it will be 9 times. Decagonal, suppose a polygon of 100 sides are there, means a path of 100 times it has been changed. So that means 100 times force is needed, because 100 times the body will be accelerated at each corner. What about 1000 side polygon or path? Similarly, if we take a polygon or a path with n number of turns, n number means very large number of turns. So as per definition of circle, if circle is a polygon with infinite number of sides, that means due to continuous change in direction, because there are n number of large number of turns, so it will almost become a shape of circle. Now, so ultimately, if you keep on increasing the path, turns, corners, will finally come to what kind of path? We will come on the circular path. So, moving ahead to the concept of circular path. So, at a circular path with n number of sides, that means infinite number of sides, so infinite turns, and as we observed, for every turn we require force. So, can we say when the body moves on a circular path, it requires all the time to move with a change direction, and if all the time the move of change in direction is required, that means there should be all the time a force which keeps on changing the direction of the moving object. But take care here also that we are not giving credit to the force to bring change in the magnitude of velocity. Here the force is only being used for continuous change in direction of the body when it is moving on a circular path. So on a circular path, a body requires force all the time, because all the time at every instant it has to take a new direction. So finally the body is moving on a circular path with constant speed, and this is only called uniform circular motion.